My name's Cassie Weishaupt, and I'm a data scientist with SIL International. I'll be presenting about artificial intelligence tools as quality assessment co-pilots in the Bible translation process. In our paper, we claim that artificial intelligence tools can act as co-pilots, helping stakeholders in the translation process to efficiently and thoroughly evaluate certain qualities of a draft translation, even when these stakeholders do not fully understand the process that has been used to produce the translation. I would like to start with a disclaimer that this presentation, of course, doesn't cover everything in the paper. If you would like to learn more about any of the topics I'm covering in this presentation, we would encourage you to refer to the corresponding section of the paper. That being said, this presentation is organized as follows. First, I will define artificial intelligence, or AI, introduce the concept of AI as a co-pilot, and also introduce our augmented quality assessment tool, AQUA, which is an AI co-pilot for Bible translation quality checking. Then, I will go over appropriate expectations and workflows for AQUA. I will talk about how we are anchoring AQUA's quality assessments in reality. I will describe the qualities that AQUA measures and how it measures them. I'll briefly touch on the results from some of our AQUA field trials. And finally, I'll wrap up with some concluding thoughts. So we can't begin a discussion on artificial intelligence without first defining it. There are many definitions of artificial intelligence, but the one we'll refer to is the ability of a computer or other machine to perform activities that are normally thought to require intelligence. Now, under this definition, we can think of lots of examples of AI. Here are a few in order from least to most complex. Calculators. Whenever you use a calculator, you're using a machine to perform an activity that is normally thought to require human intelligence. In this case, that activity is performing mathematical operations. A more complex example is search engines such as Google and Bing, which use artificial intelligence to give you the most relevant search results based on several factors, including your search query, your location, and your past search history. Machine translation engines such as Google Translate use artificial intelligence to translate text or speech from one language to another. And finally, a very popular example of artificial intelligence is, of course, ChatGPT and other generative large language models. Before we go any further, it's important to note that artificial intelligence is not the same as human intelligence. Even though artificial intelligence may achieve similar results as humans on certain tasks, and in some cases seem eerily human in its behavior, under the hood, it's all just a result of sophisticated programming and mathematical algorithms which are designed by humans, rather than a replica of human thought processes. Artificial intelligence does not have a conscience, it is not sentient, it does not experience emotions, and it cannot practice subjective reasoning. In the AI world, there's been a lot of talk recently about so-called AI copilots. One popular example is GitHub Copilot, which makes suggestions as programmers are writing their code. There's also an AI copilot in Google Workspace that will make next word suggestions as you're writing in a Google Doc. Many of you have probably made use of this tool. Now, the use of the word copilot highlights two very important points. First, there's a person, or a pilot, who is in control of the process. And second, the pilot's work is enhanced in some aspects, for example, in efficiency or creativity or in thoroughness, when they're assisted by the AI copilot. Let's look at an example of AI copilots from the medical field. Radiologists go through years of training to be able to examine X-rays and provide a diagnosis. They're very good at what they do. However, radiologists and other physicians in some hospitals, such as UC San Diego Health and at Stanford, are now reaping the benefits of using AI copilots to augment lung imaging analysis. In fact, these copilots are allowing for early detection of life-threatening conditions. In one case, a patient in the emergency department at UC San Diego Health who did not have any symptoms of COVID-19 underwent a chest X-ray for other reasons, but the AI copilot indicated there were early signs of pneumonia, and a radiologist later confirmed this finding. Curtis Langlotz, a professor from Stanford who works in this field, puts it this way: will AI replace radiologists is the wrong question. The right answer to this wrong question is radiologists who use AI will replace radiologists who don't. Now, what about Bible translation? Could AI copilots act as probes into the big three qualities of accuracy, naturalness, and clarity? We argue that they can. In this paper, we introduced the Augmented Quality Assessment Tool, or AQUA for short, which is being developed as an AI copilot for the Bible translation quality checking process. Let's consider the case of a translation consultant performing a quality check on a Bible translation draft. Like radiologists, consultants go through years of training to become very good at what they do. In this case, diagnose possible quality issues in a draft. AQUA is also able to locate issues within translation drafts, within a matter of minutes, actually. However, not everything AQUA identifies will be a problem, and it'll fail to identify certain edge cases that a consultant would be able to find. When a consultant's work is enhanced by AQUA, they are able to perform their checks not only more efficiently, but also more thoroughly, allowing them to spend more of their precious time prioritizing the parts of the draft that most need their attention. In fact, one of our consultant test users estimated that using AQUA helped him to do his final consultant check 10 to 20% faster, while helping him find 10 to 15% more possible areas for revision to discuss with the translation team. Another consultant expressed a similar sentiment. AQUA is finding things that a consultant should notice, but doing it faster. Now, in order to understand how AI-driven tools can best be integrated into quality assessment workflows, we need to, 1, have reasonable expectations about what AI can do, and 2, identify the potential users of this technology and how they might use it. We must have reasonable expectations as to what a tool like AQUA can measure. The premise of this symposium is that translation quality is best approached as a set of several qualities rather than as a single entity. It is important to recognize that AQUA only measures a very specific subset of translation qualities, that is, measurable intrinsic qualities of the translation product. In addition to these measurable qualities, AQUA can also measure and visualize the consistency, or sometimes inconsistency, of these qualities across books, chapters, and verses as a sort of meta-quality. If AQUA is a co-pilot, that means that there is a person piloting the quality assessment process. Who is this pilot? Well, it depends on what workflow is involved. We focus on 3 major workflows in the translation process and how AQUA can help. The first group is those who are tasked with evaluating translation products and processes, such as administrators, strategists, and funders. AQUA offers them analytics so that they can make more informed decisions about the benefits of various methodologies and products. The second group is those who are tasked with checking a draft translation consultants. AQUA offers them power tools, helping them to check a translation more thoroughly and consistently within the time available. The third group is those tasked with creating a new translation, translators. AQUA offers them an early warning system, helping them to address obvious problems before a draft is submitted for checking. To those who do not understand the technology, AI tools can be a mystery. They may feel more like science fiction than science reality. Why should we expect stakeholders in the translation process to begin relying on the quality metrics produced by such tools? We are anchoring AQUA's methods in reality by, first, grounding the metrics by relating them to the known qualities of existing translations. Second, interpreting the metrics in relation to the aspirational qualities of the translation project. And third, explaining the metrics so as to be understandable and replicable. Let's look at an example of how we ground our metrics within the landscape of existing Bible translations using AQUA's word correspondence metric. Word correspondence is based on the statistical distribution of words in the verses of the target text in comparison to the distribution of the words in the source text, and is explained in more detail in the paper. This graph depicts the landscape of word correspondence of several well-known English translations to the lemmatized source Greek New Testament. We see that the translations on the left side of the graph, which exhibit lower word correspondence to the source Greek, are more dynamic translations, such as the Message and the Living Bible. On the right side of the graph, we have translations that exhibit higher word correspondence to the source Greek, such as Young's Literal Translation and the King James Version. Now, we apply the same metric to non-English translations. By plotting the results in the same landscape diagram, it becomes possible for someone who cannot read these languages to get a sense of how these translations compare in this aspect of translation style to a number of known translations. Note, for example, that the Spanish Reina Valera translation, which is often considered to follow a similar translation style as the King James Version, has a very similar mean word correspondence score to the KJV. Similarly, the Nueva Versión Internacional is close to the New International Version, which both share very similar translation philosophies. When interpreting our metrics, it's important to note that a given score for a measurable quality is not inherently good or bad. These scores must be interpreted in light of the goals stated in the translation brief. That's why we are developing a configuration template for users to input relevant information from their translation brief into Aqua. Aqua will then use that information to calibrate its reporting, and the user will be able to interpret their scores in comparison to other relevant translations. Here, we see a heat map of word correspondence scores for the Book of Acts in a dynamic South Asian translation compared to the lemmatized source Greek. These are not raw scores. These scores have been calibrated against other dynamic translations from the same language cluster. The top and bottom 4% outliers have been highlighted here, representing what is out of bounds when compared to other dynamic translations. Blue cells are verses from this translation that have unusually low word correspondence scores to the Greek when compared to the other dynamic translations in the cluster. Likewise, the red cells represent unusually high word correspondence. Interpreting these results in light of other similar dynamic translations enables Aqua to ground its reporting in reality. When working with AI, it is important to design metrics that are explainable and replicable. As AI has grown and become more widespread, there is a movement within AI ethics typically called responsible AI. A systematic review of ethical guidelines of 84 companies found that the top principle in 87% of these companies is transparency. That is, people affected need to know how the AI got the result. Transparency in experiments is a concept that has existed for a long time in science, including in linguistics. Computational research is no different, which is why we strive to present our methods in a way that is explainable and reproducible. And that leads us into our next section, our methods of assessment. In the interest of time, I will only explain our methods on a high level. If you would like to learn more about how we are producing our metrics, please refer to the corresponding section of our paper. We group our metrics according to the big three aspects of translation quality: accuracy, naturalness, and clarity. Under accuracy, we have two metrics that rely on word correspondence: formal equivalence and missing and added words, and another metric, semantic similarity. Under naturalness, we measure sentence and word length as a proxy for readability. And under clarity, we have a comprehensibility question answering metric. We will begin by talking about word correspondence. Simply put, we can calculate word correspondence between two biblical texts by attempting to align functionally equivalent words between them. We can do this for texts in any written language, in any script, as long as there is a clear way to delineate words. For example, in many scripts, white space acts as a word delimiter. However, we have found that results are more accurate for isolating languages as opposed to polysynthetic languages. Resulting word correspondence scores represent how much each word in each source verse corresponds to each word in each target verse. We use these scores as a proxy for formal equivalence by averaging out scores over verses, chapters, and books, and also as a way to identify potential missing and added words by comparing these scores across translations. Our semantic similarity metric measures whether two biblical texts are saying the same thing, even if their words don't correspond well to each other. In order to do this, we use the language-agnostic BERT sentence embeddings model, or LabC for short, from Google to encode the source and target verses. This results in a vector, or a list of numbers, that represents the meaning of a verse. The training data for this model includes 109 languages of wider communication, so LabC is most accurate for these languages. Therefore, for most semantic similarity assessments, we use a back translation. We can determine how far apart these resulting vectors are from each other by calculating the cosine similarity between them. This is a measure of how similar the meaning of two verses is. Our current readability metric is a simple measure of words per sentence and characters per word on the chapter level. We realize that this metric will not work well for many of the world's languages and scripts, and does not take into account other factors that influence a text's readability, such as syntax and word choice. Therefore, we are doing research into alternative methods of approximating readability that would work in a more language-agnostic manner. Finally, I present our comprehensibility metric, which is still under development. Our comprehensibility metric uses automated question answering to locate potential missing or added information within a verse. We begin by generating a dataset of question and answer pairs for each verse, aimed at ensuring important content is present. We then take each verse from a back translation of the draft, feed it in as context to the question answering model, and ask it to answer the corresponding question based on that verse. We compare the generated answer to the gold standard answer from our dataset. If they are significantly different, we flag the verse, as this may indicate that the verse does not contain the correct information to answer the question. So now I'll present a couple of examples of these assessments in our Aqua user interface. So one example will compare two published translations to each other, and the other will use an unpublished translation. So our first example compares two English translations, the Good News Bible, which we have selected here, and the New American Standard Bible, which we have selected here. In this hypothetical example, we're treating the Good News as the draft text and the NASB as the reference. What you see here is a heat map of word correspondence between the two translations, with each row representing a book of the Bible and each cell representing a chapter in that book. So for example here, this first row is Genesis, this first cell is Genesis chapter 1, Genesis chapter 2, and so on. The cells on the green end of the spectrum represent verses exhibiting higher word correspondence between the two translations, and the cells on the red end of the spectrum represent verses exhibiting lower word correspondence. On this book level view, we observe some interesting patterns. For example, the genealogies in the first few chapters of 1 Chronicles are very green, right here, while the wisdom literature books are more red, so that's Job, Proverbs, and Ecclesiastes, and this doesn't really come as a surprise. We also see that the first 5 books of the New Testament, down here, which are narrative or mostly narrative, are generally greener than the following epistles. If we scroll down, we can see our semantic similarity heat map between these two translations where we see similar trends. Now I'm going to show you one example that is of particular interest. Here I've zoomed into the chapter level, so the heat map here is only showing Matthew chapter 3. We see that Matthew chapter 3 verse 8 stands out with relatively low scores for both word correspondence here and for semantic similarity here. If I scroll down to the verse table, which is down here, I can see the verse text side by side along with the word correspondence and semantic similarity scores that Aqua has assigned to them. And here I can see that this verse, Matthew chapter 3 verse 8, is in fact translated very differently between the two versions. So the Good News translates it as, "Do those things that will show that you have turned from your sins." The NASB says, "Therefore bear fruit in keeping with repentance." This view also highlights words in the reference, so the NASB, that may not have an equivalent in the draft text, the Good News. Let's focus on the red words here on the right, as those are the words that Aqua is most confident are missing. In Matthew 3:6 here, Aqua has let us know that the word translated river in the NASB has no clear equivalent in the Good News, and we can confirm that this is the case. The Good News just says, "They confessed their sins and he baptized them in the Jordan," not the Jordan River or the River Jordan. Similarly, in Matthew 3:3, we see that the word voice in the NASB is missing from the Good News translation. What the NASB translated as "the voice of one crying in the wilderness," the Good News rendered "someone is shouting in the desert." So, hypothetically, if the Good News Bible were undergoing a consultant check with the NASB as its model translation, verses like the ones Aqua just pointed out, where the draft and the model translation differ the most in these aspects of quality, would be of particular interest to the translation team. Now I'll show you an example of our comprehensibility assessment relating to an ongoing translation project in South Asia. Here we ran a comprehensibility assessment on an English back translation of the local language draft for the Book of Ruth. Unfortunately, I'm not able to demo this in our interface currently as it's still under construction, but I'll just show you some examples here. I've pulled up two of Aqua's flags for this back translation. In the first column, so here, you'll see the verse reference. In the second, you'll see the text from the back translation. In the third, you'll see a question from our data set pertaining to this selected verse. And then in the fourth column, we have the expected answer to the question in column 3. And in column 5, we have the inferred answer that our question answering model gave to this question based on the verse text here in column 2. Now, there are two cases where Aqua will raise a flag for the comprehensibility assessment. The first is if the expected and the inferred answers are indeed similar, but the model is not confident that it has the right answer. So that's the case for our first example here. The back translation for Ruth 1:12 reads, "Return, my daughters, go on your way, for I am old enough to have a husband," when it should probably read something like, "I am too old to have a husband." Because the model was not confident in answering the question here in the third column, what does the mother say she is too old to do, based on this verse text, Aqua has flagged this verse as needing extra attention. The second case where Aqua will raise a flag is when the expected answer and the inferred answer are significantly different from each other. In the second example here, and it's a bit of an extreme case, we can see that the verse text is talking about Paul, not about Ruth or Naomi. This verse was likely accidentally pulled from somewhere in Acts. When asked the question, who saw that Ruth was determined to go with her, based on this verse text, the model understandably answers Paul, not Naomi, and this verse is flagged as well. And now I present a brief overview of our Aqua field trials run thus far. We've run 5 Aqua field trials since October 2022, with several more currently underway. The languages included in these field trials are linguistically diverse and use a variety of scripts. Test users have included both mother tongue translators and consultants, many of whom have reported that Aqua helped them gain new insight into the status of their draft translations. Several use cases have come up during these field trials, including comparing a working revision of a published Bible to its model text, highlighting areas where most revisions have been made, comparing 2 snapshots of the same translation project from different points in time to each other, highlighting the changes made throughout the course of the project, comparing a draft to the source Hebrew or Greek, which is often of interest to translation consultants, comparing a draft or a back translation to a model translation to gain insight into how closely the draft is following the model, and comparing a draft to its corresponding back translation to gain insight into how accurately the back translation conveys the information in the draft. To read about these use cases in more detail, please refer to the corresponding section in the paper. In conclusion, Bible translation should never be an AI-centric process. It should always be done by people who are being guided by the Holy Spirit. We introduced an AI co-pilot called Aqua, which is a tool for these people involved in the translation work, designed to help with just one small part of the quality checking process. With the help of Aqua, stakeholders in the Bible translation process can better focus their attention on those parts of the task that really need their expertise and gain new insight into their translations. Thank you.